Welcome back, everyone, to the eCoreAcademy e-learning platform. My name is AJay Raj, back with yet another Algebra 1 video for you all, and today we're going to be looking at simplifying radicals. Now, you may have heard of radicals in previous time. Basically, the square root symbol is essentially known, but today we're going to dig deeper into more properties of the radical and also different ways that you can actually see problems with the radical. So before we jump into today's video, please make sure to do 4 things. Please make sure to hit that subscribe button, hit that like button as well, turn on post notifications, and don't forget to click that bell icon, the post notification bell, so you don't miss out on any of our latest uploads. So as I was saying, we're just going to be looking at how you simplify radical expressions, taking a look at the radical, identifying its properties, and simplifying radical expressions, just like you would simplify fractions that are essentially sometimes improper fractions or fractions that you must need to simplify within themselves because you can divide into each other. So it's always important to simplify. We're going to look at radical. So, introduction. What exactly does a radical expression look like? Well, as you can see up on the screen, a radical expression essentially has that little very unique mark to it in the center. Obviously, in the middle, on the right-hand side, within the actual radical symbol, we have the x value, which is your radicand. This is the number that actually goes within the radical. It's a number that's essentially being square rooted. The radical represents a square root if it doesn't have an index. So your index is obviously the root in which you want to root it to, essentially. So if there's no index value there, it's automatically a square root. However, if there is an index, like a 3, a 4, then it's going to be a cube root, so on and so forth. Now let's take a look at one of the major properties of the radical, essentially radical expressions, and this is the product property. So it's called the product property of square roots. So the product property of square roots states that if you have a radical of AB, so the square root of AB as shown, that's actually equivalent to the square root of A times the square root of B. So essentially you can divide up those two terms that are being multiplied together, AB, and it's equivalent to this multiplying their separate square roots together. That equals their combined product entirely square rooted as a whole. So essentially this occurs when both A and B are both greater than or equal to 0. So obviously they can never be negative numbers. Remember, you can never discover a negative square root in this case. And obviously a negative square root is non-existent because there's no two numbers of the same identity that can be multiplied together to get a negative, because 2 negatives multiplied together is a positive, 2 positives multiplied together is a positive. So it's impossible. All right, so now let's take a look at some practice, really looking at that the square root property. So let's use this product property of square roots to simplify square roots. So I'm going to be throwing up a couple problems here, and let's see how we can actually divide up these different radicals and see if we can simplify them into smaller chunk-sized bits. So essentially the goal here is when you're trying to simplify radicals, essentially simplify radical expressions, what you're trying to do is you're trying to simplify, see what's inside the radical, essentially the value inside the radical, and you're trying to discover if you can split it up into smaller squares, so essentially. So smaller squares, the more squares you break it up into, the more you can simplify it and divide it up into separate pieces. All right, so let's take a look at the square root of 20. We're trying to find the largest square that goes into 20. And if we think about factors of 20, the main one that I can actually think of is 4. So let's take 4. So we're going to keep our radical here, our radical symbol, and we're going to put 4 here. And then obviously 4 times what equals 20? That's going to be 5. So 4 right here is going to be our largest possible square that goes into 20. So the way to split this up and simplify it is we're going to simplify the square root of 4. Remember, we can always split this up into the square root of 4 times the square root of 5. And if you look over here, this is a perfect square. So obviously square root of 4, that's going to equal 2 in this case. So this merely simplifies to 2 times, obviously, square root of 5. It's not a perfect square. So it's 2 times the square root of 5 here. All right, now let's move on. Now let's take a look at the square root of 50. Let's think about the largest square that fits into 50. And obviously that's going to be 25, so 5 squared. So we're going to split that up. So we have 25 times 2 equals 50. Obviously, we can break this apart into 2 separate radicals. So square root of 25 times the square root of 2. And we can simplify the square root of 25 as 5, essentially, because 5 times 5 is 25. So that's going to be 5 times the square root of 2. And then lastly, let's take a look at something as large as 200. So the first thing that comes to mind is obviously it's a product of 100, our largest possible square here. So this is going to be 100 times 2. We can simplify that here by literally splitting it apart. So square root of 100 times the square root of 2. We know that the square root of 100, that can be simplified to 10, because 10 squared is 100. So we're left with 10 times root 2. Let's take a look at some more practice on the right-hand side. So now we have the square root of 63. We can simplify this down, and we can see obviously that the largest square here is 9. So that's going to be 9 times 7. That equals 63. Obviously, we can split this up into a square root of 9 times the square root of 7. The square root of 9 is actually 3, so we're left with 3 times the square root of 7. Then, of course, here we're given an actual a value multiplied by the actual radical, so 4 times the actual radical of 98. So let's see if we can simplify 98 and multiply that to 4. So we take a look at 98. So even when you're trying to take a look at the simple properties of this, you want to first start by maybe dividing it by 2 in this case. So when you divide this entire value by 2, you're given with 49. You always want to start somewhere when it's an uncomfortable number, like 50, 220, 63. Those are things that we actually memorize with simple product rules. But 98 is a little bit uncomfortable. So let's divide 98 by 2. That's always the safest way to go, bifurcating it. So when we simplify that, we're left with 4 times the square root of 49 times 2. And there you have it. 49 is actually going to be our perfect square within the radical itself. So what we're going to do here is, obviously, we're going to split this up. We have 4 times the square root of 49 times the square root of 2. We can simplify the square root of 49 to 7. So now we're left with 4 times 7 times the square root of 2. So obviously 4 times 7, that's going to be 28. So it's just going to be 4 times 7 times the square root of 2. Obviously, we can simplify 4 times 7, that's 28, and then multiply it to our root 2, because that's in a radical. And for our last problem, obviously the square root of 36. This is fairly simple here. It's a smooth square number, something that you always love to see. Square root of 36, obviously 6 squared equals 36, so our answer is merely going to be 6. All right, so now let's continue with some more practice. So now we're going to kind of switch up the process. We just simplified the radicals from their unsimplified format, but let's take it to the reverse manner. Let's take a simplified radical and try and change it back into its improper form. So what was the square root essentially before multiplying it out? So let's take a look at this simplified square root, this simplified radical expression, so 3 times the square root of 10. So obviously, what we're going to do here is, we know that since 3 was taken out of this original radical here, we know that whenever you take one value out, you also have another value inside. Because remember, when you're square rooting, say for example, you have the square root of 9 here. That splits up into the square root of 3 times 3. And obviously, you're canceling out 1 3, and then you take that 1 3 out of the expression, essentially. So in order to get to this 3 being out here, we need to square root something. So what is essentially 3 squared? Well, 3 squared equals 9. Since 3 squared equals 9, that means that 9 has to be within the radical because we're square rooting it. So we must multiply that with 10. That's already in the radical. That gives us the square root of 90. And if you go back and simplify that, we can split 90 into 9 times 10, obviously. Reverse the process. 9 is a perfect square, so that 3 goes outside of the radical. Same thing on the right-hand side. Let's take a look at this expression. So we have 5 times the square root of 3. The square root of 3. And well, essentially how we got to this 5 is we had to square root a value. So what exactly is 5 squared, the reverse? 5 squared is going to be 25, obviously. So now what we got to do is we got to multiply 25 back into the radical since it was being square rooted. So we're left with 25 times 3, and that leaves us with the original radical of square root of 75. All right, perfect. Now let's move on. Now let's take a look at multiplying radical expressions. So we're going to be taking a look at these various radical expressions here, and obviously we're going to be trying to simplify these radical expressions with essentially variables. So these multiplied radical expressions involve variables being multiplied. So not just digits now, we're also involving ourselves with variables. So if we take a look at this equation here, you might be confused. How in the world do I split up x to the 9th? Well, consider the property. Remember, whenever you're square rooting something, that means one item is being multiplied to its identical, literal identical self to get to that value there. So obviously we can split up 63. We know we're going to start off with our known digit here. We know that the largest square in 63 is 9, so it's 9 times 7 that we're left with, and then times x to the 9th. So what exactly are we going to do with x to the 9th? Well, remember, it's a square root that we're looking for. And if we're looking for two identical values to be multiplied to each other, well, essentially what we're going to be looking for is the largest possible even number that fits into your exponent. Well, the largest possible even number is going to be 8. Now think about x to the 8th here. Let's pull out x to the 8th. Well, if we look at x to the 8th, what is the square root of x to the 8th? It's actually fairly simple. So what two values that are the same multiplied to x to the 8th? Well, x to the 4th times x to the 4th, that literally adds up to x to the 8th, because you're always adding exponents when you multiply them together, when you multiply these bases together. So that's x to the 8th. So all you're doing is you're taking the largest even number that goes into the exponent of that given term, x to the 9th, in this case is 8, and then you're literally splitting that value in half. So we're splitting that value in half so that you can multiply them together, add them together essentially to get that value again. So we're going to split this up further into 3 times the square root of 9 times 7 times x to the 4th times x to the 4th, so 2x to the 4ths. But remember, we also have that missing x to the 1st that we took out to get to x to the 8th, so we're also going to put in that x to the 1st. So when we simplify all this, obviously you can take out your 9, so that's going to be a 3, that's going to be multiplied here, so 3 times the square root of x to the 4th times x to the 4th times x to the 1st. Right. So now what we're going to do here is we see that x to the 4th here and x to the 4th here are both being multiplied together. Obviously, since you have two of the same term, you can merely cancel out one of these terms. But in this case, you see here we have x to the 8th being the original term of this. We know that the square root of x to the 8th is going to be x to the 4th. So these two we can cancel out, and we can multiply x to the 4th on the outside. So we're left with 3 times x to the 4th times the radical square root of x to the 1st. We don't need to simplify further unless it asks. But obviously that is our simplified term. However, this would just merely be 9x to the 4th times the square root of x to the 1st. All right, let's take a look at another example here. So 2 times the square root of 18x to the 11th. So obviously, first off, we're going to try and break apart our known digit here at 18. And the largest square in that is going to be 9, so 9 times 2. We're left with 9 times 2 times x to the 11th. The next thing that we're going to try and do is we're going to try and find the largest even number that goes into 11. That's obviously 10. Not largest even number up to 11. So the largest even number that goes up to 11 is going to be 10. That's within 11 and 0, so that's 10. So we're left with 9 times 2 times x to the 10th. And obviously, we can split apart these terms now. We know that x to the 10th square rooted is going to be x to the 5th, because it's just x to the 5th times x to the 5th. You divide it in half. And then obviously, 9 here is going to be 3 squared. So we're going to take out that 3, put it here, and we're going to take out 1 x to the 5th and put it out here. So we're left with, obviously, our 2 times 3 here, and then our x to the 5th, times, lastly, our x to the 1st. Because remember, we took out the x to the 1st when we got to x to the 10th here. So I'm going to add that x to the 1st here, that odd x out. So let's simplify this. So we get 2 times 3 is 6. So 6 times x to the 5th times the square root of x is our final answer. All right, so now let's move on to the last ending part of our very video here on simplifying radicals. Let's take a look at a very challenging word problem. Well, from the likes of it, word-wise, it can be fairly confusing, but when you break it apart and use your simple properties, it's actually quite simple. So this is an ice cream cone problem. Let me read it out to you. So a light fixture in an ice cream cone is in the shape, essentially, of an ice cream cone. The cone's height is 7 times the radius. The slant height, essentially the side of that cone, if you think about a cone, the side of the cone, the slant height of it is equivalent to the square root of the height and the radius squared. So what is the slant height of the cone? All right, so let's take a look at this equation. This should have said the square root of the height squared and the radius squared. They're being squared separately and added together. So let's take a look at this problem. So let's solve this problem. So this is essentially what we're looking at, this cross section here. If you think about a traditional cone, it essentially looks like something like this. All right. Well, but the only thing that we're really focused on is the radius here, that little base here, the height of it, which is going all the way through the cone, and obviously the slant height here. So this essentially forms a right triangle. So now we're only focused on this right triangle here. So if we go back to the problem, we see that we have the cone height is 7 times the radius, essentially. And obviously, the slant height is equivalent to the square root of the height squared and the radius squared. So let's start plugging in those values. So essentially, we're given our radius here. It's going to be this bottom part here. Flipped, it doesn't matter which one it is. This is obviously our slant height. So this is our slant height. And then, of course, our radius here. The radius in this case is actually going to be 3. R is going to equal 3. So we're given that the radius is going to be 3 units. And then, of course, our height here, this overall height is going to be 7 times the size of the radius. That's already given here, 3. So we know that this side here is going to be 21 in this case. So now all we're left with is finding the slant height. However, we're going to use the formula that they already gave us. The formula that they gave us was the slant height is equivalent to the radius squared plus the height squared square rooted, essentially. So now that we have the height and we have the radius, we can plug those values in. So we have that our slant height here is equivalent to 3 squared plus our 21 squared in this case. What exactly does that simplify to? Well, we simplified 3 squared to 9 here in this case. And then obviously 21 squared. We can multiply that over here on the side. 1 times 1 is 1, 2, 0, 2, 4. That's going to be 441. So we're going to plug in 441 here. So when we simplify this here, what we can essentially do is we can take this property here, this radical here, and we can simplify it further down. All right, so now we're going to add these together here to make this one compact term. So 9 plus 441, that's going to be the square root of 450. The next thing that we're going to do is we're going to try and find essentially a prime factor of 450. So the first thing that we're going to do is think about any of your prime factor that you know. Well, I don't want to use 1. I don't want to start off with 1 either, or 2, because this isn't necessarily going to be smooth with 2. So let's try something with 3. We know that 45 is a smooth factor, or a product of 3. So let's split this up by 3 and 150. 3 times 150 in this case. So once we split this up, obviously this isn't the only way that you can do it. You can always split it up into any way that you want. You will get to the same answer when you break it apart. So we're left with 3 times 150 in this case. So when we take a look at 3 times 150, what we're going to do here is we're going to break apart what 150 is. So 150 is essentially 15 times 10. So 3 times 15 times 10. That's the property of 150 in this case. But, however, we can break apart these values even further, essentially. So once we break these apart, we know that 15 is made up of 3 and 5. So that's 3 times 5. And then obviously 10 can be broken apart into 5 and 2. So 3 times 3, 3 times 3 times 5 times 2. So this is completely factored out. What we basically did here, since it was such a complex term, we literally prime factorized it. So we took all the prime factors of this radical and we broke them apart. So as you can see here, one thing that should really stand out to you all is that we have 2 3s here and 2 5s here. So the first thing that we're going to do is we can immediately cancel out these one of these 3s and take one of those 3s outside. Same thing with the 5. We can automatically cancel out one of the 5s and take the other 5 outside because 3 times 3 is 9, and 9 is essentially 3 squared. So we can take out one of those 3s and cancel out the other one. So when we take that here, it simplifies to 3 times 5 times the square root of 2. 3 times 5 is 15. So we're left with 15 times the square root of 2 is our slant height in units squared, in our units. All right, everyone, so that'll be it for today's video. This has been the eCoreAcademy e-learning platform. Please make sure to like and subscribe down below. Feel free to hit that post notification bell, and also feel free to share using that share button on the YouTube homepage as well. Check out our website at www.ecoreacademy.org. Email us at ecoreacademy@gmail.com if you have any questions, and check out all of our socials at Pinterest, Facebook, Twitter, Instagram, and TikTok to see what kind of cool content we have out there. All right, everyone, this has been AJay Raj. I hope you guys enjoyed this video, and I'll see you guys in the next one. Peace.